Imagine trying to figure out a way to keep a track of 1 trillion conversations at once, with millions more sent each second, storing all of them basically forever. Luckily, we don't have to imagine, since the Discord devs have given us 2 articles to understand it. Unluckily, it's really hard to understand if you're not an SWE and don't immediately understand what a blob is. So let's start easy. Not 1 trillion messages, not even 1 billion. Just a few million and a few explainers to how Discord stores trillions of messages. CTO Vishnevsky talks about starting off with MongoDB and planning to switch to something later. Why? Because MongoDB is great for quick iteration. It's built on a NoSQL database, which makes it flexible and does not require a fixed structure or schema in official terms. NoSQL databases typically just store data in a format called documents, which are like JSON objects that you can play around with, instead of rigid formatting like its traditional counterpart. But isn't that terrible for large amounts of messages? Yes, but remember that this was in the early months of Discord, where they wanted to get features in extremely quickly and test them, so being able to do that without having to change the entire database over and over again was an extremely valuable thing to have. Imagine if you wanted to get some new blankets. You can just get some new blankets. You don't need to throw out the house that comes with it. Inevitably, you have to change, and so we come up at our first major decision at the 100 million message mark. What now? At this point, the article goes into a lot of depth about reads, writes, and data, but all you need to know is that people either sent a ton of messages or nothing at all when they used voice chat a lot, and that the read pattern, when the server needed to pull messages, was completely random. This essentially meant 3 things and a preference for open source. 1. Whatever was to be adopted needed to actually work. 2. It should scale and, frankly, fix itself if possible. 3. It shouldn't be a blob store. Now hold on a second. What the hell is a blob store? Well, think about it. What is a blob? It's a mass of stuff. That's what a blob store does. The blob, or binary large objects, which is just text or images or whatever, is stored in binary format. The important distinction here is that it's raw, which means that every time someone wants to read something, remember what read means? The system would have to deserialize the blob, essentially making it comprehensible for us humans. It should be pretty obvious why that would be a terrible idea. All that meant that they ended up adopting Cassandra, an open source database backed by DataStax, which was already being used by Netflix and Apple. What is Cassandra exactly? Vishnevsky describes it as a KKV system, because it is a KKV system, which is exactly what it sounds like. The first K is the partition key, which decides where the data is stored on different servers. Inside each partition, there are multiple rows, and the second K is the clustering key, which sorts the rows in the partition. You can think of a partition like an ordered list of items. This list of items was fitted to what Discord needed, which our CTO here summarizes for us here. And everything's perfect. Except it's not. Speaking of, thanks so much for all the support on the channel lately. It really means a lot, and I want to give something back to you guys. So do you need a job? That sounded a bit weird. But whether you're a UX designer, app developer, freelancer, or just a curious viewer, I want to get to know you guys, share some UX and UI tips, and maybe even get a gig. So I made a Discord channel for us and want to make this the place to be for front-end professionals. And I'm having talks with people to get some employers in there so you can connect with them too and find some jobs in the future. I'm really excited to get this thing started, so I hope you'll join me. Scroll down on the article and we have something freaking out about partitions. What's going on here? It sounds complicated, but what it boils down to is that you wouldn't tell someone to attempt to sprint full force in a marathon, just like it's a bad idea to constantly push Cassandra to its 2 GB partition limit. As the article says, just because it can doesn't mean it should. Pushing it too far affected something called compaction and cluster expansion, which I'm just gonna slap the Google explanations for on screen since it's not too important. What is important is that the team realized they had to make their message buckets smaller. Now that we know this, we can zip past the rest of the article, with the only really notable thing being that they fixed a glitch in Cassandra's database, which was displaying the author ID as null. We end off the article with a very happy picture of Vishnevsky and a nicely running Discord, until we eventually get to billions and trillions of messages, and everything falls apart. 6 years later, Bo Ingram, a senior developer, explains in an article that's not any less complicated than the last one how Discord managed this giant wave of popularity that probably had something to do with the fact that Skype was just dead and TeamSpeak's UI looked like some knockoff of Craigslist. We start off with our friend Cassandra being overloaded, the on-call team being overworked, and the financial side completely on fire. But why? This is where we mention that Cassandra is node-based, each node handling its own message buckets. Now, imagine a node with 2 servers on it, a server with 200 people in it, compared to a server with 1 trillion. The node has to serve both, but all the performance is getting drained into the server with 1 trillion people, and the 200 people server is now getting shafted, and that's not good for a user experience. The partitions getting a ton of traffic are metaphorically overheating. That's what hot partition stands for here in the article. The on-call team constantly being called was for the consequences of this, but specifically the garbage collection, which is just deleting old stuff no one needs anymore, was constantly overwhelmed and led to lag spikes everywhere. This all led to ScyllaDB taking over the reins. Because it was C++, it's just better than Java. In our previous iteration of this post, we mentioned being intrigued by ScyllaDB, a Cassandra-compatible database written in C++. Its promise of better performance, faster repairs, stronger workload isolation via its shard-per-core architecture, and a garbage collection-free life sounded quite appealing. For the sake of the video, we can just leave the comparison at that. But what we can't leave is the fact that Discord implemented ScyllaDB and then just didn't migrate the message database over from Cassandra. What? It doesn't really make sense on the surface, but migrating trillions of messages is hard. It's great to have ScyllaDB here to help, but if the migration was screwed up, then there wouldn't be anything to migrate at all anymore. The only things left to deal with were hot partitions and migration. Scylla doesn't do hot partitions well either. It's tremendously technical, but it really boils down to this. When too much traffic came in, it affected the traffic after, and then again and again, leading to cascading lag or latency. They needed to solve this, so they chose to stick in a middleman called data services using Rust, which can regulate the flow of traffic like highway ramp traffic lights. Rust and its library, Tokyo, specifically was really good at concurrent writing. This meant that it was super easy for the program to handle hot partitions, and coincidentally, also easy to migrate everything, since writes could be made at the same time, the ones being made to Cassandra, and the ones being used to migrate from Cassandra to Scylla. The team spun up a very cool-looking migrator to do this, Scylla Spark, and then beamed all the messages from Cassandra over at a rate of 3 million a second. And the job's done, and stuck at 99.9999%. The last 0.0001%, the team compacts away, the job's done, and Bo Ingram's happy face is at the bottom of the page now that you actually know how Discord stores trillions of messages. But what about videos? And what about YouTube?